Hey everyone, it's Jad here. Today we're tackling the LeetCode problem, longest repeating character replacement. I'll walk you through how I'd solve this in a coding interview, from understanding the problem and devising a plan, to coding, testing for errors, and evaluating time and space complexity. I'll be solving this problem in Python, and I'll think out loud and ask clarifying questions just like in a real interview scenario. Let's get started. So I'm given a string S, an integer K, and we can choose any character of the string, change it to any other uppercase English character, perform this operation at most k times. We want to return the length of the longest substring containing the same character. Okay, so if I sum it up, as input, I'm given a string S and integer K. And in the string S, we can change characters to some other uppercase English characters. So I do have a question here. Can the characters be, the initial characters can be something else than the uppercase letters? If we look into the constraints, that's not the case. So we only have uppercase English letters in the string S at any time. And so we want to return the length of the longest substring as the output that contains the same letter with the changes. Okay, let's now try to better understand the problem with these examples. So here, if we look into this, I have two A's and two B's, and as I can make at most two changes, I can either replace all the B's or all the A's, so the result would be 4. Now let's look into this other example here. When I see this problem, I'm thinking of using a sliding window. So let's say my right side start from here at 0. I have A, so I have one character. For now, I can move forward. Yes, because I have two A's, and here I can still move forward because K is equal to 1, right? I can still move forward, but now I have 3 A's and 1 B, and as I've already used my operation, I cannot move forward. So the idea would be to now, increment left side as long as I do not have enough operations left. So here in this situation, no. In this situation, I can move forward because now B is the leading character, right? And I have only one change here, and here I have this. So I have maximum 4 in these two situations. Because then when I move forward, I do end up with the result is equal to 4. Okay, now let's try to implement this now that I've kind of a solution in my head. So I want to start with left equal 0, and from collections. So when I was looking into one given window, I think the right thing to do is to actually use a hash map. So I'm importing from collections counter. So left is 0, and I also want to have frequencies as counter. And for right in range, so let me call n the length of S, right? I have the length of S. And the thing is, I'm iterating over this, and I also want to keep track of the result. So let's start with 0. One thing to note is, yes, I have a few questions. What are the constraints on S and K? So we can see here that K is between 0 and S of length. And S is never equal to 0. It's never empty string. So, okay. And as it is between 0 and S length, we know that if K is equal to S length, well, it means that I can change all the characters, right? If I can change all the characters, it would be N. But I don't think we need to actually define these use cases, edge cases here. I'll confirm that by the end of the implementation. So I have my right, and the first thing I want to do is actually put the element into the frequency counter, right? So frequency right is, it's not right that I'm putting in here, but S right is incrementing frequency. And once I do have this, what do I want to do? So I have my first element, and I want to keep track. So I start from here. So I'm here, my right is here. So I just added this one in here. And in the result, so the result would be the maximum, right? Between result and right minus left plus 1. So let me count this here. So maybe not. Actually, I want to, so let's take this situation here. We want to get quickly the frequency of the letter that has the highest frequency. So because that would allow us, like, let's say here it would be 2, which means that we can immediately get the number of letters in this window that are not A, and see if we need to, reduce the interval, right? So highest frequency is going to be maximum of frequency dot values, right? This is the highest frequency. And one thing to note is, okay, let's say I'm here and I want I have 3 A's and 1 B. Now, if I want to move forward, let's say I'm in this situation. One thing to note here is that we might want to, this is not possible because we have 3 A's and 2 B's. And so we want to reduce the length of the interval as long as we are not satisfying the condition, right? So while what's the condition here? So right minus left plus 1 gives us the total number of letters in the interval, minus highest frequency is superior to K. Well, we need to update left and also remove it from frequency. There we go. For me here, So what am I doing here? Let's try to apply my algorithm here. So, okay, I'm getting the length of n 2, 4, 6, 7. So it would be 7. I'm starting with left is equal to 0 and right is equal to 0 and result is equal to 0. So in the first situation, I am adding a here. Okay, I've added this one. Then I'm getting the highest frequency, which is equal to 1. Then I'm checking right minus left plus 1 is 1. Minus highest frequency is 1 is 0. And 0 is strictly inferior to k. So we do not end up here. And what we do is we so the length, maximum length is 1. So we are updating it to 1 here. Next, I'm adding a again. Now the highest frequency is 2, and the length is 2, so it's 0, so we do not end up here. Then here, I have the highest frequency is 2, but the length is 3, so which means that it's one letter that is not counted, but it's still equal to k1, k being 1, so we do not end up in this while loop. Here it's the same. We have 3 with a length of 4, so we do not end up there. And now there's a problem because this is added, so we have 3 and 2. 3 for A and 2 for B, which means that the length is 5, minus 3 is 2. 2 is strictly superior to K, which means we need to remove things out. And what are we doing? So we are removing this first letter, and we are incrementing left. We are then removing this first letter again, because in this situation, what do we have? We have 2, so the length is 4, 4 minus 2 is 2, and so we have 2 letters to convert. That's not good, so we do this again, and here it is 2 B's and 1 A, so we no more need to increment, and we end up with the result. Now let's try to, so that's it. Let's now try to run this. There we go. Let's now try to submit this solution. It works. Let me now analyze the time and space complexity for these, for my solution. I'm iterating over the length of S here, and so right is only moving forward this way, and whenever we do have issues, we increment left, so it's O of n for the time complexity, and the space complexity in the situation where so here I implemented it with a counter, but I could improve it with an array, for example. If I create an array of length 26, because we know that there are only uppercase English characters, then well, it's O of 1 actually, because the array size is fixed. We cannot have more than 26 characters. So I would give O of 1 for the space complexity here. It's an approximate. That's it.